Students, we are discussing microbes in industrial products, right? In this microbes in industrial products, we completed fermented beverages. And now we are discussing about antibiotics, right? We are discussing about number 2, antibiotics. Antibiotics. The first antibiotic that was discovered, penicillin. The first antibiotic that was discovered. What is the first antibiotic that was discovered? Penicillin. And who discovered this antibiotic? Alexander Fleming, right? Who discovered this penicillin for the first time? Alexander Fleming. And this discovery of penicillin by Alexander Fleming, is a chance discovery, right? Discovery of penicillin by Alexander Fleming is a chance discovery. For chance discovery, we can use another technical term, that is serendipity. What is the meaning of serendipity? Chance discovery. Therefore, discovery of penicillin by Alexander Fleming is a chance discovery. There is a serendipity. Alexander Fleming, he worked on Staphylococcus bacteria. Alexander Fleming. What is the scientist name? Alexander Fleming. Worked on which bacteria? Worked on Staphylococcus bacteria. Worked on which bacteria? Staphylococcus bacteria. Sir, what is the meaning of coccus? Coccus means spherical shaped bacteria. Yes or no? Coccus means what shaped bacteria? Spherical shaped bacteria. Then what is the meaning of Staphylococcus? A group of spherical shaped bacteria arranged regularly or irregularly? Irregularly. Therefore, Staphylococcus bacteria, a group of what shaped bacteria? Spherical shaped bacteria. Group of spherical shaped bacteria arranged irregularly. Group of spherical shaped bacteria arranged irregularly, that is Staphylococcus bacteria. Now listen the work of Alexander Fleming. Alexander Fleming, he worked on which bacteria? Staphylococcus bacteria. So what Alexander Fleming did means he started culturing this Staphylococcus bacteria. While culturing or growing which bacteria? Staphylococcus bacteria. While culturing or growing Staphylococcus bacteria in culture plates. I already told you, culture plate, petri dish, which is used for culturing of microorganisms. Culture plate is also called as a petri dish. It is used for culturing of microorganisms. Alexander Fleming, when he started growing this Staphylococcus bacteria in what? culture plates. Then what Alexander Fleming observed means, Alexander Fleming observed that in one of his unwashed culture plates, in one of his unwashed culture plates, at some places there was no growth of Staphylococcus bacteria. There was no growth of Staphylococcus bacteria. There was no growth of Staphylococcus bacteria. This was observation of which scientist? Alexander Fleming. Therefore, Alexander Fleming, what he observed that in one of his unwashed culture plates. Which culture plates? Unwashed culture plates. There was no growth of bacteria. Actually, he want to grow this bacteria, but in one of his unwashed culture plates, there was no growth of this Staphylococcus bacteria. Then he got a doubt. What is the reason why Staphylococcus bacteria was not growing? Why Staphylococcus bacteria was not growing in some places of unwashed culture plates? This was his doubt, right? Now, for example, this is a culture plate. This is a culture plate. In this culture plate, he started growing which bacteria? Staphylococcus bacteria. Started growing which bacteria? Staphylococcus bacteria. Staphylococcus bacteria. Now see this culture plate. In this culture plate, at some places there was no growth of Staphylococcus bacteria. There was no growth of Staphylococcus bacteria. Then he got a doubt. Alexander Fleming, he got a doubt. Why there is no growth at some places of unwashed culture plate? In unwashed culture plate, at some places there was no growth of Staphylococcus bacteria. What was the reason? Then what he did means he observed this culture plate under microscope. When he observed this unwashed culture plate under microscope, when he observed this unwashed culture plate under microscope, he found that there was growth of a mold. There was a growth of what has taken place? Growth of a mold has taken place. Where the growth of mold has taken place, at that place the growth of Staphylococcus bacteria was prevented. What has prevented? Growth of Staphylococcus bacteria was prevented. Who prevented the growth of Staphylococcus bacteria? A mold. Alexander Fleming, he identified that this mold is nothing but Penicillium notatum. He identified that this mold is nothing but what? Penicillium notatum fungi. Penicillium notatum fungi. It clearly indicates that growth of Penicillium notatum fungi has inhibited the growth of Staphylococcus bacteria. Yes or no? Growth of Penicillium notatum fungi has inhibited the growth of what? Staphylococcus bacteria. How, sir? This Penicillium notatum fungi secreted a chemical. That chemical has inhibited the growth of Staphylococcus bacteria. Penicillium notatum fungi, it has secreted a chemical. That chemical has inhibited the growth of Staphylococcus bacteria. Sir, that chemical is produced from whom? That chemical is produced from Penicillium notatum fungi. Yes or no? That chemical is produced from Penicillium notatum fungi. That's why that chemical was named as penicillin. What was that chemical named as? Penicillin. It means Penicillium notatum fungi has secreted a chemical which has inhibited the growth of Staphylococcus bacteria. That chemical as produced from Penicillium notatum fungi, that chemical is named as penicillin. That chemical was named as what? Penicillin. This was the discovery of penicillin. Now listen these statements carefully. While growing Staphylococcus bacteria in culture plate, who is doing this work? Alexander Fleming. Alexander Fleming observed that in one of his unwashed culture plates, at some places there was no growth of Staphylococcus bacteria. There was no growth of Staphylococcus bacteria. Then Alexander Fleming, what he did? He observed unwashed. What he observed? He observed unwashed culture plate under microscope. Observed unwashed culture plate under what? Microscope. Then he identified that at some places growth of a mold has taken place. What has taken place? Growth of a mold has taken place. This mold secreted a chemical. Who secreted a chemical? This mold has secreted a chemical which prevented or inhibited, which prevented the growth of Staphylococcus bacteria, which has prevented the growth of what? Staphylococcus bacteria. Later he identified the mold. As a Penicillium notatum fungi. Later he identified the mold as what? Penicillium notatum fungi. Penicillium notatum fungi. And he named the chemical as what? Penicillin. Why he named this chemical as penicillin? As it is produced from Penicillium notatum. As this chemical is produced by Penicillium notatum, he named that chemical as a penicillin. Therefore, these statements clearly indicates that penicillin has inhibited the growth of Staphylococcus bacteria. penicillin has inhibited the growth of what? Staphylococcus bacteria. What has inhibited the growth of Staphylococcus bacteria? Penicillin. Who secreted this penicillin? A fungi by name Penicillium notatum. Yes or no? Now listen these statements. We are discussing work of Alexander Fleming, right? In work of Alexander Fleming, what happened? Penicillium notatum, it's a fungi. What it did? Secreted a chemical. Yes or no? Secreted a chemical. That chemical was named as a penicillin. What this penicillin did? Penicillin inhibited growth of Staphylococcus bacteria. Staphylococcus bacteria. Now listen here. This Penicillium notatum is a fungi which is a type of microorganism. Right. This Staphylococcus bacteria, it is also a type of what? Microorganism. It means this is a type of microorganism which has inhibited the growth of another type of microorganism by producing a chemical. What is that chemical name? Penicillin. So this penicillin, it becomes what? Antibiotic. Yes or no? Because chemical substances produced from microorganisms which inhibits the growth of other microorganisms, which inhibits the growth of disease causing microorganisms. Yes or no? We can call that chemicals as antibiotics. Therefore now this penicillin becomes what? Antibiotic. This penicillin becomes what? Antibiotic. Now listen this statement. Sir, here the chemical secreted by one microorganism has inhibited the growth of another microorganism. So can we call this concept as biological antagonism? Yes. What it is? Biological antagonism. Biological antagonism. Name itself indicates bio means life or living. Sir, microorganism, they are living. Yes or no? Antagonistic. Antagonism means opposite. It means the chemical secreted by one microorganism is acting against the growth of another microorganism, preventing the growth of another microorganism. So we can call this concept as biological antagonism. What it is called as? Biological antagonism. Biological antagonism. Now listen this statement. Antibiotics are antimicrobial. Yes or no? Antimicrobial. Antibiotics are antimicrobial. Sir, why we are calling antibiotics as antimicrobial, sir? Anti means opposite. They are acting against microorganisms. So we are calling antibiotics as antimicrobial. But microorganisms are of different types. Sir, they are acting on which type of microorganisms? Generally, antibiotics acts on bacteria. Generally, antibiotics acts on bacteria. So, antibiotics are generally antibacterial. Antibiotics. Antibiotics generally acts on which microorganisms? Bacteria. So antibiotics are antibacterial. Is this statement okay? Antibiotics generally acts on bacteria. Generally they are acting on what? Bacteria. So antibiotics, they are antibacterial. Antibiotics are antibacterial. They are antimicrobial, right? Antibiotics are antimicrobial as they act against microorganisms. Antibiotics, they act against microorganisms. So antibiotics are antimicrobial. Sir, we are saying that antibiotics acts against microorganisms. Generally, antibiotics acts against bacteria. Antibiotics generally acts against which microorganisms? Bacteria. That's why we are calling antibiotics as antibacterial. Antibiotics are generally what? Antibacterial, as they act against what? As they act against bacteria. As they act against bacteria. These antibiotics, they are used to treat different types of diseases. Antibiotics. Antibiotics are used to treat different types of diseases. Used to treat different types of diseases, such as number 1, plague. Number 2, whooping cough. What it is? Whooping cough. In Hindi, we are calling this whooping cough as a Kali Kansi. This whooping cough is in Hindi called as what? Kali Kansi. Next, number 3, Gal Gotu. What it is? Gal Gotu. Actually, this is a Hindi word which means diphtheria. Which means what? Diphtheria. Next, number 4, leprosy. Leprosy is also called as Kust Rog. Leprosy is also called as what? Kust Rog. It is also called as Kust Rog, right? Therefore, antibiotics are used to treat different types of diseases. Used to treat what? Different types of diseases, such as plague, whooping cough, nothing but Kali Kansi. Next one is diphtheria, there is Gal Gotu. Next one is leprosy, there is Kust Rog. Now listen this statement. Penicillin was the first discovered antibiotic, right? This penicillin was used by Americans during Second World War to treat injured American soldiers. Therefore, penicillin. Penicillin was extensively used during Second World War. Penicillin was extensively used during Second World War to treat injured American soldiers, right? Therefore, penicillin was extensively used. Penicillin was extensively used during Second World War to treat injured American soldiers. Penicillin can be used as an effective antibiotic. This statement was given by Chain and Flory. Therefore, according to Chain and Flory, according to whom? according to scientist names I am writing, according to Chain and Flory. According to Chain and Flory, penicillin. Penicillin can be used as an effective antibiotic. According to Chain and Flory, penicillin can be used as an effective what? Antibiotic. Effective antibiotic. Is it okay? Right. In 1945, Chain, Flory, Alexander Fleming, right, they got a Nobel Prize for this work. They got Nobel Prize for this work, right. In 1945, Chain, Flory and Alexander Fleming, they got Nobel Prize for this work. Is it okay? Right. Now listen this statement. We are saying that antibiotics are produced by microorganisms, right? The organism which produces antibiotics, that organisms are called as antibionts. What are the organisms called as antibionts? Therefore, what are antibionts? What are antibionts? Organisms which produces antibiotics are called as antibionts, right? Right. Now listen here. Organisms which produces antibiotics. Organisms which produces antibiotics are called antibionts. Antibionts, right? Now listen this statement. Bulk of antibiotics. Bulk of antibiotics. Bulk means large quantities, right? Bulk means large quantities. Bulk of antibiotics are produced. Bulk of antibiotics are produced by three groups of organisms. By three groups of organisms. It means a large quantity of antibiotics produced by how many groups of organisms here? Three groups of organisms. Sir, what are the three groups of organisms, sir? First one is eubacteria. What is the first group? Eubacteria. Second one, actinomycetes. Second one is actinomycetes, right? And third one is fungi. What is the third one? Fungi. What is the first one? Eubacteria. Eubacteria comes under kingdom Monera, right? Therefore, it's prokaryotic. Number two, actinomycetes. Actinomycetes also comes under kingdom what? Monera. So it is also prokaryotic. What and what are prokaryotic? Eubacteria and actinomycetes. Both are prokaryotic. They comes under kingdom Monera. Go for last one. What it is? Fungi. Fungi comes under kingdom fungi. It is eukaryotic, right? What it is? Eukaryotic. These are three groups of organisms which produces bulk of antibiotics. Now see this statement carefully. Listen this statement carefully. Sir, eubacteria can produce antibiotics, actinomycetes can produce antibiotics, fungi can produce antibiotics. Yes or no? It means both prokaryotic. and eukaryotic organisms can produce antibiotics. What and what can produce antibiotics? Both prokaryotic and eukaryotic organisms. I am not saying that all prokaryotic and all eukaryotic organisms. Just I am saying that both prokaryotic and eukaryotic organisms can produce right what? Antibiotics. Both prokaryotic and eukaryotic, both prokaryotic and eukaryotic organisms, both prokaryotic and eukaryotic organisms can produce what? Can produce antibiotics. Can produce what? Antibiotics. Is this statement okay? Right. Now, sir, eubacteria, actinomycetes and fungi, these are three groups of organisms which can produce what? Antibiotics. Now go for the first one. Go for first one. Number one, what it is? Eubacteria, right? Eubacteria. More than 70% of antibiotics produced from eubacteria are produced by a genus by name Bacillus. More than how much? 70% of antibiotics produced from eubacteria are extracted from which genus? Bacillus genus. Which genus? Bacillus genus. Therefore, more than 70% of antibiotics which are produced from eubacteria, okay, more than 70% of antibiotics which are produced from eubacteria, they were extracted from which genus, sir? Bacillus genus. Extracted from Bacillus genus. It means from alone Bacillus genus. Okay, from alone Bacillus genus. Okay, more than 70% of antibiotics of eubacterial antibiotics were extracted. Right. Next important statement, right, 30%. How much percentage? 30% of eubacterial. 30% of eubacterial antibiotics. 30% of eubacterial antibiotics were extracted from Pseudomonas. Pseudomonas genus. From which genus? Pseudomonas genus. Listen these statements carefully. More than 70%. More than 70% of eubacterial antibiotics are extracted from Bacillus genus. Right, 30% of eubacterial antibiotics are extracted from Pseudomonas genus. Extracted from Pseudomonas genus. Pseudomonas genus. Right. Now, sir, more than 60 types of antibiotics. How much? More than 60 types of antibiotics. More than 60 types of antibiotics. More than 60 types of antibiotics are produced by a bacteria by name Bacillus subtilis. What is the bacteria name? Bacillus subtilis. More than 60 types of antibiotics are produced by a bacteria by name Bacillus subtilis. Bacillus subtilis. Right. Now go for number 2. What is the second one? Actinomycetes. Actinomycetes. I already told you Actinomycetes means branched filamentous bacteria, right? What is actinomycetes? Branched filamentous bacteria. Actinomycetes means branched filamentous bacteria, right? More than 40 types. How many? More than 40 types of antibiotics. How many? More than 40 types of antibiotics, right, are produced. More than 40 types of antibiotics are produced by streptococcus, are produced by streptomycin, are produced by whom, sir? Streptomyces. Streptomyces. See this statement once. More than 40 types of antibiotics are produced by streptomyces. Sir, streptomyces comes under what? Actinomycetes. Streptomyces comes under actinomycetes. We completed second one, right? That is eubacteria. And what is the second one? Actinomycetes. Now we are going for third one. What it is? Fungi. What is the third group of organisms from where antibiotics are extracted? Fungi. Sir, which fungi, sir? Penicillin. Which fungi, sir? Penicillium. Penicillium, right? Therefore, sir, eubacteria, actinomycetes and fungi, these are three group of organisms. These are three groups of organisms from where bulk of antibiotics, large amounts of antibiotics are extracted. Large amount of antibiotics are extracted. Now listen this statement. Take a penicillin. What it is? Penicillin. Penicillin generally acts on cell wall. Penicillin acts on what, sir? Penicillin acts on a cell wall. Sir, penicillin acts on cell wall. Do mycoplasma contain cell wall? No. So penicillin cannot act on mycoplasma. Why, sir? Because penicillin acts on cell wall. Mycoplasma does not contain cell wall. Therefore, penicillin cannot inhibit the growth of mycoplasma. Penicillin acts on cell wall. As a mycoplasma, what it is? Mycoplasma is with or without? Mycoplasma is without cell wall. Mycoplasma is without cell wall. Penicillin cannot inhibit growth of mycoplasma. Cannot inhibit the growth of mycoplasma. Now listen this statement. Take another antibiotic by name tetracycline. What is the antibiotic name? Tetracycline. This tetracycline antibiotic, it interferes with metabolic pathway of disease causing microorganism. Therefore, it acts on tetracycline acts on what, sir? It acts on metabolic pathway. It acts on metabolic pathway of microorganism. Sir, mycoplasma, right, is with metabolic pathways. Therefore, tetracycline can inhibit the growth of mycoplasma, but penicillin cannot inhibit the growth of mycoplasma. These statements we already read in, right, first year in biological classification chapter, right? Therefore, sir, tetracycline acts on metabolic pathway of microorganisms. So, tetracycline So tetracycline can, what it can do? It can inhibit growth of mycoplasma. Sir, what is this mycoplasma? Mycoplasma is the smallest living organism, right? Mycoplasma is the smallest living organism. It's the smallest living organism, right? Thank you.